Welcome to Study Loop.
Given the function f of x equals 2x to the fourth minus 11x squared plus 9, we want to find all the possible rational zeros and an interval in which all the zeros lie for the function. So the possible rational zeros are going to be the factors of the constant, which are positive and negative 1, 3, and 9 over the factors of our leading coefficient, which is 2. So that's 1 and 2, which means it's positive and negative 1 over 1, 1 over 2, 3 over 1, 3 over 2, 9 over 1, and 9 over 2. So that's possibilities. An interval which all zeros must lie. Well, we can find bounds. So our smallest upper bound, what we're looking for, that'd be 2x to the fourth, no x cubed, negative 11x squared, no x plus 9. What we're looking for when we synthetically divide is a quotient row that is all positive. When it's all positive, that's an upper bound. So if we drop down the 2 and multiply and add and multiply and add, okay, it's not 1. So let's try 2. We drop down, multiply, add, it's not 2. We go to 3. We drop down the 2, we multiply, add, add, all positive. So 3 is an upper bound. For a lower bound, we'll do negatives, and we're looking for an alternating signs in our quotient row. Drop down the 2, multiply, add, add. Okay, we're not alternating signs, so it's not negative 1. Let's try negative 2. Drop down the 2, multiply, add, add. It's not negative 2 because we're not alternating signs. We'll try negative 3. Drop down the 2, multiply, add, 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 and we're alternating signs, positive, negative, positive, negative, positive. So they must exist in the interval from 3 to negative 3 to 3. Which means that we don't have to test like 9 or 9/2, or they're negative because they live beyond the realm of possibilities. So now we want to factor to linear and irreducible quadratic factors. Okay, so let's test to see if 1/2 is a 0, because we already saw 1 wasn't, and 3 is not either, and 9 cannot be. We tested 1 and negative 3, and neither of those are 0, so we didn't get a remainder of 0. So let's try 1/2. What we're looking for is a remainder of 0. Drop down the 2, multiply, add, add. I'll do that as a fraction. That would be negative 21/2. Multiply would be negative 21/4. And that's not going to be 9. So 1/2 is not. could try negative 1/2. Drop down the 2. That would be negative 1, add, multiply. This one's not going to be either, so let's try the 3/2. And hopefully we're striking luck here. Drop down, multiply, you'll get 6 halves or 3, add, then you'll get 9 halves. And then negative 22 plus 9 is negative 13 halves. And then this would be negative 39 fourths. And then that multiplied by 3 halves. Isn't working either. Let's graph. When all else fails, 2x to the 4th minus 11x squared plus 9 I think I glossed over something that's going to be helpful. I glossed over the fact, I guess I was going off of memory, that 1 and negative 1 didn't work, but according to the graphs it's going to, so let's show that it does. 2, 0, negative 11, 0, 9 should get a remainder of 0. Drop down the 2, multiply, add, multiply, add, multiply, add, multiply, add. Sure enough, 1 is a 0. Negative 1, we could use the leftover quotient row, drop down the 2, multiply, add, multiply, add, multiply, add, and sure enough, negative 1 is a 0. And this leaves 2x squared minus 9 equals 0, or 2x squared equals 9, or x squared equals 9 halves, so x would equal positive and negative square root of 9 halves, which is well, let's go like this. If we have quadratic factors, and we know x minus 1 and x plus 1 are factors, that's x squared minus 1 as a quadratic factor. This quadratic factor would be x squared minus 9 halves. Or you can say 2x squared minus 9 if you'd like.